Okay, this is the P1 paper from January 2023. It's question number 6. And as we can see by looking at this one, this is a radians question. We're going to be working out arc lengths, we're going to be working out areas of sectors, etc. Just give you a little bit of time to read through the question, or you can stop the video. And all the information that's here needs to be put onto the diagram. So it tells me that this is a sector of a circle OBC, centre O, joined with two congruent triangles either side of it, OAB and ODC. Let's start putting the information on then. It says the angle BOC is 2.4 radians. Okay, so that angle there's 2.4. It tells me that the area of the sector is 40 metres squared. That's the area of this sector OBC. It tells me AOD is a straight line of lengths 12.5, but remember it just told me that these were both congruent, so that means that that's 6.25 and 6.25. And then what does it say? It says, can we find the radius of the sector, giving our answer to 2 decimal places? Well, yeah, I should be able to do that. We'll just go through and do that bit, then we'll have a look at the rest of it and just work our way through it. So if it's asking me for the area of a sector, I know the area of a sector is equal to a half r squared theta. And in this particular one, we know the answer, which is 40, and we know that the angle is equal to 2.4. So the only thing we don't know is r there, so we can just rearrange all that. We're going to get that 80 is equal to 2.4 r squared, and so r is going to be the square root of 80 divided by 2.4, and that means that r comes to 5 point, and then I'll do 77 meters, because going back and looking at the question, it said to 2 decimal places there. So not too bad for part A. Part B, find the size of the angle AOB in radians. So let's just put 5.77 on the diagram just in case we need it later on. Sorry, it says, yeah, find the size of the angle AOB. So AOB is this angle here. And if we want to work out that one, well, yeah, if you think about it, those two are going to be the same as each other. I'm up here looking at the diagram. Those two are going to be the same as each other because it's congruent triangles. So one of them is just going to be 2 pi, the complete straight line here, 2 pi, minus the 2.4, and then that divided by 2 will give us the answer for AOB. I told you, but let's tell the examiner that. So AOB is just going to equal 2 pi minus the 2.4, and then that all divided by 2. So do that on your calculator. That works out to be 0.37 radians. Again, in the question it asked to 2 decimal places there. So we've done both A and B. Now for part C, it says find the total area of the stage. All of this thing is a stage here. Find the total area of the stage and give your answer this time to 1 decimal place. So let's just make it clear to the examiner how we're going to work that out. So C, the area of the stage is going to be the area of the sector, and then plus the area of the 2 triangles, plus area AOB. Something's coming with the pen, apologies. AOB and the triangle OCD, but obviously those two are the same as each other, so if we work out one of them, we have to get it for both of them. So the area of the sector, we already know that, that's 40, and the area of each triangle is going to be a half BC sine A. We can now say times 2 for that. So that's going to be 40 plus a half. What are the lengths? We've got 5.77 and 6.25, and we've got obviously that the angle was 0.37. So it's that times 2. Well, if it's times 2, I'll just get rid of the half there. So what does that all work out to be? Remember, we wanted it to 1 decimal place. That works out to be 53.1 square meters. So we've done part C as well there. And again, just making sure that we go through, don't want you to lose any of these silly marks here for decimal places, etc. Find the total perimeter of the stage, giving your answer to 1 decimal place. So the perimeter of the stage, just be careful, it's not all the lines, is it? But it's this line, the arc length, and then this line and this line again. And obviously we have some of those already. We've got that those two are 6.25 each, or that it's 12.5, depends on how you want to set out your answer for that. Basically, we need to work out the length of CD, and we need to work out the length of the arc length there. So let's go ahead and do those and tell the examiner what I'm doing, and then we can get on and do it. So part D, so I would say what the perimeter is first of all. So the perimeter is going to be the arc length. Now you could put plus CD, plus I'm going to put plus 2 lots of CD, just to save myself a little bit of time, and then plus our 12.5 at the bottom. So just decide which one you're going to do. I'm going to do CD first. So for CD, we're just using the cosine rule. A squared is B squared plus C squared minus 2BC cos A. Got all the information that we need in there. So CD squared, don't rush through this though, is 6.25 squared. It's 5.77 squared minus 2 lots of 6.25, 5.77 cos, and then just make sure you're getting the right angle this time, 0.37 when we're doing that one. I'm just going to go straight to the answer for that. We've got enough that we're doing here. I'm going to do that one to 2 decimal places, and then if I do everything to 2 decimal places at the end, I can just correct it. Arc length then. L is just equal to r theta. So in this case, L is going to be 5.77 times 2.4. So that works out to be 13.85. All these lengths are meters here. And then just sum up everything, get everything together. So perimeter is equal to the arc length, which was 13.85 plus 2 lots of that 2.26, and then plus 12.5, and if you add all those together, the answer works out to be 30.9. And again, go back at the very end of these ones, just make sure you have done them all to the right number of decimal places and significant figures each time, because we don't want to be losing marks for that in what should be a relatively straightforward question with that one. Diagram not too complicated, so hopefully that all makes sense.